Hey everybody, so I just wanted to make a couple notes. First of all, as I said in my email, there was a problem with the OpenStax homework assignment. And so as of now, you have two assignments that are listed due on Friday at midnight. They're both identical, except one of them has 14 questions and one of them has 11 questions. You want to do the one with 11 questions. And note that it has, in the title, Take Two. The reason is that Tutor does this thing where it puts these personalized questions, and I've sort of battled with it, and finally I got them to take it off, and so you're not required to do the personalized questions. And I don't have those in the Take Two, so you do this one. Do not do the other one. Some of you have already done it, but just transfer your answers over to the other one, to the Take Two. That's the one that you'll want to do. Also, I'm going to postpone the homework assignment until Saturday at midnight. You'll see that show up in your tutor assignment box soon, that I'll have it due on Saturday at midnight, so that just to give you a little time. And then in this little short video, I want to address a couple issues, or really just one issue that came up, because in Tutor, in this way that they present the cardinal directions, it's a little bit different than what we did in class. So let me just show you. Anytime you're dealing with a vector problem, it's a good idea to draw a figure. And so I'm going to do that first. Here I have a bird flies 2 kilometers south, 2 kilometers, like that. And then he flies 1.5 kilometers, 37 degrees east of south. Now this is east and this is south. Let me draw this again over here. So remember before we said, and this is, let's see this one, north, that's east, north, south, west, and south. And I said before that if I give you an angle, I'll give it like this, and that this angle, for example, would be south of west. But OpenStax, in the way that they present this problem, and it's a fine way to do it, but what they do is they flipped it, and instead of saying south of west, now they're saying east of south or west of south. And what that means is, to go east of south means that I go 37 degrees east of south. And so this vector is 1.5 kilometers at 37 degrees east of south. Right. And then my net vector, the straight line path, which is what it wants, I want to know how far does it have to travel if it travels back in a straight line. That's going to be that distance. Then you go through the same process wherein you find the y component, and then you find the x component, and then you find I can move that x component down here, and then notice that I have a right triangle right here, and so I can add up my x and y components and find the hypotenuse of that triangle. Now one more thing I want to show you, because I'll show you on this question, which is similar. I'm just going to look at this first vector, this 12.2 kilometers at 35 degrees west of north. So 35 degrees west of north, this is north, this is west. 35 degrees west of north looks like this. Now remember, I said that if we have a vector A, then the x component of A is A cosine theta. But I also said that this cosine is dependent upon theta being measured from the x-axis. And notice here that theta is not measured from the x-axis, theta is measured from the y-axis. And so to find, I'll just find the x component for this vector. You'll need to do the y component for this vector, and then also the x and y components for the second vector. But if I want to find the x component for this vector, notice the x component is this component of the vector. And then if I were to draw the y component, it would look like that. So I'll call this vector A, this is AY, and then this is AX. Let's redraw this just a little bit. I'm just going to draw it as a right triangle. That's what we're dealing with. This angle is 35 degrees. That means that this angle is going to be, what's that, 55 degrees. So you can do two things. This angle, by the way, is 35 degrees. You can do two things, and either one will give you the same answer. You could say that AX is equal to A cosine of 55 degrees. And then that'll give you the X component. And that's fine. So whenever you have an angle that's measured off the y-axis, just do 90 minus that angle to find the angle as measured off the x-axis. But if you're clever with your trig functions, you'll see that you can also say that AX is equal to A times sine of 35 degrees. And that'll give you exactly the same answer. So I can take that, gosh, what's it called? I think it's called a complementary angle, where they add up to 90 degrees. That I can take that angle and take the sine of it. And you should be able to see now why that is. That if this is A and this is AX and this is 35, well, the sine of 35 is equal to opposite, that's AX, divided by the hypotenuse, which is A. So, on these, two things that I want you to recognize. One, the cardinal directions for these are measured off of the vertical axis. West of north, east of south, those are measurements off of the vertical axis, which we've been calling the y-axis. And then also, when you measure angles off of the y-axis, it flips that definition for the components. Or, that is where the x component is now a sine theta, the y component is now a cosine theta. Or, if that's confusing you too much, you can just do this bit, where to get the angle, you say 90 minus the angle that's measured off of the vertical axis. Listen, I'll be available. I'm not available tomorrow. I'll be out of town 6 to 6. But I'm postponing the homework assignment so that if you have questions, I'll check my email on Saturday. Send me a screenshot of your work. Send me an explanation of sort of the problem that you're encountering. If I need to, I'll even talk to you on the telephone. So if you need to give me a call, we can do that as well. But I just want you to know that I'm available. I would push it back to Monday, but I know that some of you will want to study the answers before then. So since our exam is coming up on Wednesday, I'm just going to push it back until Saturday, the due date. All right, let me know if you have any questions. You have a good day.